Hello and welcome to Module 8 in our C language series. Today's session is going to focus on console I/O. Talking about input-output operations in C, there are no keywords that we can use to perform these I/O operations, but rather we use the library functions as we've been doing so far. The input-output operations themselves have been so well designed that they're pretty flexible and cohesive, allowing us to share data easily between different devices. There's two types of input-output. There's console I/O and there's file I/O. We'll be dealing in detail with file I/O in the next session. Today's session, we will focus on console I/O. The simplest form of console I/O is reading and writing of characters, and we've already worked with getChar. But how does getChar work? It waits until a key is pressed and then echoes that key automatically on screen. So we're just going to observe this in a simple program, just that one line being executed, the rest is to be ignored. I run this now. We see getChar waiting for input. Press any character on your keyboard and that's automatically echoed on screen. getChar needs carriage return to signal end of input, so we press the enter key, and in this case that ends the program. Now looking at the complement of getChar, which is putChar, this function writes the character argument to the screen at the current cursor position. So let's go back to the same program, and I'm just going to uncomment putChar now, and we'll observe how it works. So again, getChar waiting for input. Press any character on your keyboard that's echoed on screen, needs a carriage return to signal end of input, and then putChar places the character at the current cursor position. Remember, we pressed an enter there, so now we are in the next line. Now let's look at the prototypes of both of these. We've got getChar returning an integer. The low order byte contains a character. Remember, an integer is 4 bytes, so the low order byte contains a character. What about the rest of the bytes? We'll come to that a little later. Any key represents a valid return value, including the enter, the tab, or escape. So let's now go and look at that. So if we go back to the same program and we run it, let's use a tab key here. Press enter to signal end of input, and putChar would have printed that out, but of course we can't see it, right? Because these are non-printable, coming obviously from the ASCII table. But what we can do is we can put in a printf there and use the %d in order to print the value that is stored in ch. So if I run this again now, again getChar waiting for input, press the tab, press enter to signal end of input, and putChar prints out there the tab, and we get the value 9 from the printf statement. Right, so 9 is the ASCII code for the tab key. Right, moving on. Returns EOF if an error occurs. Now what's EOF? We'll see shortly. Coming to putChar, takes as a parameter an integer, as you can see there. Only the low order byte is output to the screen because that contains a character. It returns a character written if successful, or EOF again if an error occurs. But what is EOF? EOF is defined in stdio.h as a -1. That's an integer, right? And therefore both these return integer, right? Because just in case there's a failure, then they need to return a -1, and of course they'll need those 4 bytes to represent -1. Coming now to writing some code, input characters and reverse their case. If characters are in lowercase, it should be made upper, and vice versa. So let's go now to code blocks and we'll start a new file. Right, so hashtag include stdio.h, and we're going to be using functions today to check the case and change it. For that we need to include ctype.h. int main. We need just one character. We're going to use getChar and putChar. So char ch. And printf, enter some text. And now we need a loop, of course. While, when do we stop? We say while ch not equal to period or a full stop, whatever you want to call it. And then, of course, we can indicate to the user here, enter period or full stop to end. Within this loop, we'll ask for input. So ch equal to getChar. And now, of course, we need to check, right? So if is lower, that's the function we are using, and the argument will be ch, then we need to change the case to uppercase. So ch equal to 2 upper h. Otherwise, if it's not lowercase and it's uppercase, we need to change it to lowercase. So else ch equal to 2 lower and then ch. We need to print the character. So putChar ch. And of course, this loop will go on as long as the user does not enter a full stop. Let's run this now. Enter some characters. And you can see the case has been changed for each character there. Try another one. And again, the case has been changed for each character. Now you can just enter a full stop or a dot to end the program. Right? So getChar and putChar works well, but there are some problems. Buffers input until the enter is pressed. I'm going to go back to the first program. And what we're going to do now is I'm going to uncomment this block of code. So now we have ch, ch1 and ch2, all characters there, right? And what we're going to do is we're going to enter more than one character for the first getChar and see what happens. So now if I enter ASDF, for example, press enter to signal end of input, we can see now that we have A, because of putChar, we have printf execute and give us the ASCII value of ch, which is 97, of course. And then we have another getChar, but there was no waiting for input here, right? And that's because these three characters are already in the buffer. So these two getChars are going ahead and just picking that up from the input buffer and assigning them to ch1 and ch2. And then the putChar, of course, is reflecting those on screen, right? So that's what it means when it says it buffers input until enter is pressed. Those characters are then waiting in the input queue, right? And then assigned to variables according to the getChars that appear after. So you will see again that in this output, we've got S and D. We had entered ASDF. So F still remains in the queue or in the buffer, right? Another problem is it's not interactive. So what does that mean? For that, we need to look at alternatives, right? To compare rather, getChar with the alternatives, which are getch, get, and getche. Right, so now let's go back to the program and look at a demonstration of getch first. And then we look at GET-CHE. So I'm just going to uncomment this. Right, so we have CH, CH1 and CH2. When we're using GET-CH, we need to include con.io or console.io.h. Right, both GET-CH and GET-CHE are defined there. So I'm going to comment this out now so that we don't have to run that code. And let's run this now. So again, GET-CH or get waiting for input are waiting for the next input and the third input. And you can see that I don't have to press an enter first of all, right? Again, there's no chance of me entering extra characters as we had with getChar. So there's no question of extra characters remaining in the buffer or in the queue for that matter, right? So you can see how that worked. Accepted the character, put char, printed it out, then accepted the next character, put char, printed it out, accepted the third character, put char, printed it out. And of course, we had our printf print the ASCII value for the character ch1, right? Okay, so that's how get GET-CH that is works. What about GET-CHE? I'm just going to change that here and we'll observe how that works. So now if we run this, so now GET-CHE waiting for input, you can see that it echoes the character. Why? Because I have GET-CHE and then I have putchar as well, right? Again and again. So what do we deduce from here? When we use GET-CHE, we do not need putchar, right? Because GET-CHE is going to echo the character on screen, right? So now if we run this, you see, right? So that works pretty well, just like GET-CH now, but also not needing putchar. So then when will you use GET-CH and when will you use GET-CHE? If you want the characters to be seen as you type them in, you will use GET-CHE. If you don't want them to be seen, you can use GET-CH, right? And then just trap the characters and see whether it matches whatever you're looking for. Okay. So that's about GET-CH and GET-CHE. We will be using from now on one of these, right? We'll not be using getchar because we've seen the problems it has. Moving on now to reading and writing of strings. So we have Getters, which reads strings of characters, places them at the address pointed to by its character pointer argument. And we'll see this shortly when we see the prototype. Accepts input until the enter is pressed. The enter does not become part of the string, enter meaning carriage return here. The null terminator ends the string. Now we have looked at Getters, we have written our own version of it, and we also know that it's deprecated, but it's important to understand the inner workings of Getters. Its complement is putS. It writes strings of characters, outputs string arguments to screen, followed by a new line character. So every time putS executes, or rather after it finishes execution, we will see the cursor on a new line. Right? And we'll see a demonstration of both of these shortly, but first let's take a look at the prototype. So we have the prototype for Getters, and you can see that it returns a pointer to a character, right? And of course takes as argument the character array, right? So it's putting the characters we type in into the address indicated by this argument. Okay, that's Getters. putS returns an integer and takes as argument again the character array. Now putS requires much less overhead as compared to printf. Takes up less space, runs much faster, and is used for highly optimized code. But how is all this possible? It's possible because it cannot output numbers or do format conversions like printf can, right? Also, it returns end of file if an error occurs. Now, coming to the demonstration of these, we just have simple get as str1, put as str1, get as str2, and put as str2. And these have been defined here, as you can see. So let's just run that code. So getters is waiting for input. We need to press enter to signal end of input. Remember, enter or carriage returned is not going to be part of that string. Put as then prints that string on screen and brings the cursor to a new line. Right? Waiting for the next string. Press enter. Again, the carriage return is not part of the string, and put as prints that and moves to a new line. Right, so that's how get as and put as work. Going back to our discussion on get as and put as, why get as is deprecated. We talked briefly about buffer overflow in a previous session. What does it mean? So let's now go and look at an example of this. I'm going to execute the same code, right? And we're going to put in more characters, that is more than 20 characters for both strings. It's the first string. Okay, we've entered two strings. We have got a negative return value, as you can see. And as I've mentioned in an earlier session, this error indicates that we're writing in memory where we're not supposed to. Right? So now I'm going to show you yet another example of why getters is deprecated. Let's look at this one. So here we have ptr equal to str1, ptr1 equal to str2. Both ptr and ptr1 have been defined up here as character pointers. Printf enter a string, and of course we're printing out the addresses. Then we're using getters and putters. Similarly for str2. Then we'll print out the lengths, right? And we'll see what those strings contain at the end of the execution of this code. Now if we run this, okay, there's a comment symbol out there. So you can see these are the addresses now, right? So I'm going to enter the same strings. Okay, first string, enter another. This is a string we enter the second time. Lengths are 48 and 80, that's fine. str1, look what it contains. str2 contains the full string that we entered for str2, but str1 kind of has part of str2. So what's happening here? If you look at the memory addresses, this is DE0, this is DC0, this is of course for str2. So what's happening here is after we enter the second string, because there are so many characters, it's overflowing into the first string. And therefore showing us this bit, right? This is the overflow from the second string. And this is the reason that Getters is deprecated. Right? Moving on now. Summary of simple I/O operations. We have getChar, which reads a character from the keyboard, waits for carriage return. We saw that. GTCHE reads a character from the keyboard with echo, does not wait for carriage return. We also saw that it does not need the putChar, right? Because it echoes the character on screen. GTCH reads the character from the keyboard, does not wait for carriage return, but does not echo the character on screen. putChar writes a character to screen. getS reads a string from the keyboard. We know why it's deprecated now. putS writes a string to the screen, right? So these are our simple I/O operations. Coming now to write some code. Write code to create a simple dictionary. The user will provide a word and the computer will provide the meaning. So let's go back to code blocks now and start a new file. Hashtag include stdio.h. Hashtag include. We're going to be using GTCH, so hashtag include conio.h. And then hashtag include string.h, because we need string compare, strcmp. And then we need C type as well. So hashtag include ctype.h. Int main. We need to define our dictionary here. So we do that by saying char star dictionary. I'm declaring a two-dimensional array. Each row will be maximum 40 characters in length. Remember, it's not important to specify how many rows there are. It's more important to specify the length of each row in a double-dimensional array so that the compiler knows where the first row ends and the next one begins. Right, so here we're going to have constants. So, and then a comma for the meaning. Next word. And the last one is going to be just null for both word and meaning. We end this definition with a semicolon. And then we have char your word. That's going to be just 20 bytes or 20 characters. And now we have a pointer to a pointer. And another character variable that we need will be reply. Now we need to set this pointer. So p equal to just dictionary. Right, so that will be the address of the first row. And then we have a loop while to upper of reply not equal to n. So we're going to ask the user if they want to continue basically, and therefore this will be yes or no. Within this loop, we will see again p equal to dictionary. Why? Because after a search, maybe the pointers at this particular row, for the next execution of this loop, it needs to go to the top again. Right, so I hope that's clear. Printf, enter word to find meaning of. And then we'll use a scanf here. %s, comma, your word. Now, of course, we need to look for the word, right, in this array. So while star p, what does that mean? While it's not equal to null, of course. In the loop, we say if, now we use string compare, right? So if not strcmp, you're comparing your word, that is a user entered word, to star p, right? Then this means that they are equal, remember, right? So if strcmp returns a 0, it means both words match. So if it matches, what do? We can printf meaning is %s \n, but how do we get the meaning? So let's say, for example, the user typed in frowsy, right? So we had this row now, but we need to get this string. So this would be star p, for example. How do we get to that one? We can just say star p plus 1, right? Remember this from the pointers session. So we're just adding 1 to the address. So we go to the next string. We need to break out of the loop, right? So break. If not, so if they're not equal, then we just go to the next row to check. But how do we go to the next row? Or if we are at this point, for example, p plus 1 goes there, p plus 2 will go to the next row, right? So we just say p plus equal to 2. Now, when we break out of this loop, control comes here. Here we check if not star p. Then what do? Printf. The word is not in dictionary. Right? After that, remember, we need to ask the user if they want to continue. Remember, this loop will continue as long as reply is not equal to n. So here we say while to upper of reply not equal to y and to upper of reply not equal to n. We're making sure that the user types in only y or n. Right now, we don't really need 2 brackets here, so I'm going to remove one of those. Right? And within this loop, we say printf want to find the meaning of another word, question mark, yes or no. Right? So we're telling the user that they need to type in yes or no. And then we check if to upper of reply not equal to y and to upper of reply not equal to n, then printf you can only enter y or n. Right? Try again. Okay. So this completes our program. So let's go now and execute it. Here we have expected expression. Oh, sorry, this equal to should not be there. Enter a word to find the meaning of. Let's enter a word. Okay, what's happening here? Let's go and check. So here we are saying printf want to find the meaning, but we haven't asked the user for input, right? So how do we do that? Using get. So reply equal to GTCH. Let's run this now. Try that again. Meaning is kindness. Want to find the meaning of another word? Yes, say yes. Enter word to find the meaning of. Okay, let's enter ignite. Now you see it's not giving me that prompt, which should be asking me for want to find the meaning of another word. Why is that? You see, we are saying while to upper reply not equal to y and to upper reply not equal to n. Now the first time we put in a y, so it is equal to y, so it's skipping this whole thing. So to force it to go here, what we can do is at the beginning of the loop, we can say reply equal to anything other than y or n. So z for that matter, right? Any other letter. So this will force control then to go into this loop. Let's run it. Try again. Want to find the meaning of another word? Yes. Enter a word to find the meaning of. Meaning is kindness. Now it is asking me want to find the meaning of another word. You see? Yes. Enter a word to find the meaning of. Let's say, right? Now I don't want to continue. So let me type in N and that ends the program. Also, you can test for a word that does not exist in the dictionary. So going back to execute that, let's put in the word eager. That's not in the dictionary. We know word is not in the dictionary, right? Of course, then you can put in a \n. You want this to appear on another line. Want to find the meaning of another word? Yes. Enter a word to find the meaning of, and so on, right? You can put in \n so that you know the next prompt is on a new line. Now moving on. Formatted console IO. We've looked at scanf, printf. They operate on characters, strings, and numbers we know. What are the prototypes? So printf again returns an integer and takes as argument a control string, which as you can see is a character pointer. And of course, it has the argument list. The control string consists of characters to be printed and the format specifier. If we look at an example, is here represents characters to be printed. %C and %S represent the format specifiers. C and interesting represent the argument list. Right? What is the integer it returns? The number of characters that are printed on screen. Different format specifiers that we can use: %C, %D. We've used these. %I, %E and E are for scientific notation. We'll not be using these during this course. %F, %S is for strings. We've seen that. Unsigned we've used as well. %P is for pointers. To print the percentage sign itself, we use a double percentage. Right? There's a minimum field with specifier. This is an integer that can be placed between the percentage sign and the format code. It pads the output with spaces, ensuring it reaches a minimum length, and we can also have that padded with zeros by placing a 0 before the field with specifier. So let's go and look at a demonstration of this now. So I'm going to start a new file. You need not type this in. So hashtag include stdio.h int main. We'll have a double here, so let's call that double item. And let's put in a value, let's say 27.345. Printf, and this is how we can put in a minimum field with specifier. We can say %12f \n, comma, item. So let's run this now. You can see that there are spaces there as padding and then the value. But how many spaces are there? We can find that out by padding it with zeros. So printf %012f \n, comma, item. So now you can see there are 3 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus the decimal point makes it 12. And so there are 3 spaces here, right? And then of course 9 characters, including the decimal point, which makes that 12. So you see how that works, right? Moving on. The precision specifier. This follows the minimum field with specifier, consists of a dot followed by an integer. Used with strings, it specifies the maximum length. Used with floating point, it indicates the number of decimal places displayed. And with integers, determines minimum number of digits. So let's go now and look at the precision specifier. We look at it with strings, with floating point, and with integers. So going back to that same program, let's have a string. So char str1. We'll use an integer, int printf, right? So let me just comment out these 2 lines because this is our minimum field width. We don't want to get mixed up. Let's just execute this now and observe what happens. So you can see here that I've said minimum 10, maximum field width is 15. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you change that to 20, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you see how this works with strings. What about with integers? Printf. So if we run this now, you can see we have 001 to 6y because we asked for the minimum number of digits to be 5. Right? Let's try that with the float now. So printf, run this now. And you see we have 27.345 and then 2 zeros. Right? Because remember, this is giving me 5 decimal places. Right? So what we can do here to make this clearer is put in a \n so that's not confusing there. Right? So now you can see we have 27.345 00. Right? So that's 5 decimal places. I hope this is clear. Handing long and short integers. short integer. This is long integer. This is unsigned short integer and unsigned long integer. Right? Not going to do any code with that. That's pretty simple. The star and the hash modifiers. The hashtag used with hexadecimal will be printed with 0x prefix. The star used instead of constants to provide minimum field width and precision specification. Right, so let's go and take a look at that. Right, so here we say printf %x, comma, %hashtag x, and we just put in 11. Remember, hexadecimal for 11 would be B because 10 is A. So let's go and see how this looks on screen. And you can see B printed out there. But where we put the hashtag, you can see is preceded by 0x. Right, so I hope that's clear. It's pretty simple. Now to demonstrate the star, printf %star dot star f. Let's just put a backslash in there first, comma, 10, that's the minimum width, 4 is the precision we need, the value 0.43. Right? Let's run this now. So now you can see this is printed out as space, then 1456 dot, that's decimal point 4300. So it's given us for precision. And what's the minimum width? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could have a 0 there by saying \n %0 star dot star f. Right, so now you can see 0, 1, 4, 5, 6. So you can count those now. 1, 2, 3, 4, 5, 6 for the decimal, 7, 8, 9, 10. And that's 4 for precision. So I hope that's clear. Moving on. Scanf. We've used Scanf. It can read all data types, automatically converts numbers into proper internal format. This is the working, remember. So Scanf will take as input the entire characters as well as the format specifiers, right, as strings, and then place them into the variables according to their format specifiers. Returns a number of data items successfully assigned a value. If error occurs, Scanf returns EOF, which we know is -1. The prototype is like that, returning an integer. Right, as you can see, we have the control string and the argument list. The control string would consist of format specifiers, white space characters, non-white space characters. So what happens with white space characters in the control string? They're just skipped over. They're not accepted as input. With non-white space characters, like a comma, for example, they are read, right? But then they're discarded. So those two are not really taken as input. Now let's go and look at the different format specifiers, and then we look at a demonstration of Scanf. We have %c, read a single character, %d, read a decimal integer, %i as well, read a decimal integer, %f, we know reads a floating point number, %s, %x reads a hexadecimal. You know all these, %p reads a pointer, and we've used the scan set as well. We'll look at that a little later. Reading individual characters using Scanf. So we use %c, we know that. Line buffers input when %c is used. So now it's similar to what we saw in getchar, problematic in interactive environment. Let's go now and look at a demo of Scanf before we look at the scan set. We need to go back to the first program. And we'll comment this code out now. And we'll uncomment the next block of code. So this one. Here we have catch1, just an integer trapping the return value of scanf, which is asking for character and string. We then print the string, right? And we print the number of data items successfully written to by scanf. Then we have another scanf. We're trapping the return value in catch2, printing out the integer values of these characters, and then printing out the value of catch2. Right, very simple. Let's run it. And you can see scanf is waiting for input. We need to type in a character and a string. Press enter. And of course, that's a string. Number of data items successfully written is 2. It's correct, right? We have the character and the string. Now it's waiting for us to put in the characters, right, for the next scanf. So let's put in F, G, H, press enter. And you can see we get 102, which is the ASCII code for G. 103 is the ASCII code for lowercase h. But is 10 the ASCII code for F? It's not, right? What's happened here is, if you observe closely, we had pressed the enter key. That's now taken as a line feed. And 10 is the ASCII code for line feed. And that's how that 10 is printed out. Therefore, when wanting to get individual characters, we should use GETCH or GETCHE. Avoid scanf and avoid getchar. Coming now to scan set. What does this say? It says allow input of only X or Y or Z. What about this one? We've done this before, right? You know what it means. All characters to be input until an enter is pressed, or a new line character. What about this one? It says allow for input in the range of A to Z, and this one 0 to 9. Reading strings using scanf reads until the white space characters encounter. This could be a space, enter, or a tab. We know that, right? Format modifiers with scanf allows for a maximum field with specifier. That is an integer placed between percentage and the format, limits the number of characters to be read. So now going back to that file, printf enter a string scanf %10s. We are specifying the number of characters. And then printing that out, enter another fflush scanf %s str2, and then of course str2. What if I take away the fflush? Let's see what happens. So let's execute this code now. How many characters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Press enter, and you can see it's given me just 10 characters. Now you can see that the remaining character has been taken into str2. It's not waited for me to enter anything, right? And therefore, what do we do here? We need the fflush, so we can put that immediately after this. And now if we run it, enter the same string, gives me those 10 characters, but gives me the prompt as well because we flushed out the buffer. Right? So now if I enter another string, let's see, right? Prints that out perfect and the program ends. Okay, so I hope you understood this about scanf. Moving on now. How do we suppress input? Read a field without assigning it to a variable. So now let's go and look at a demonstration of suppressing input. We need to go back to the same code And we'll just comment out this block of code. And we'll uncomment this one. Right, so here we have printf enter value for string and counter. We're trapping the return value of scanf. And here you can see we have a %d. What does a star do? We will see shortly. And then of course str1 and ampersand ctr to enter the values. Remember ctr and str1 both are defined up there. Right, here ctr and then str1. Then we have the next line of code where we are printing out the values of str1 and ctr and then printing out the value of ch, which remember is the return value of scanf, right? We don't need this line actually because we're already printing that out there. We're incrementing counter by 1 and printing that value. So let's go now and execute. Enter value for string and counter. Let's enter a string. Let's enter 4 for counter. You can see string 1 is superfluous, but counter is 0. Number of data items assigned, values is only 1, and counter is 1. So what happened to this 4? Because we put the star, the scanf has suppressed input. And so CTR contains 0. Okay? That's how suppressing of input works, and this is used when you want only part of what is entered to be processed. Right, moving on now. Write code to print a string input by the user such that the string is displayed so that the first and last characters are printed first, then the second and second last character, and so on. The string should read the same as entered. So let's go now to code blocks and start a new file. Before we start the code, just an idea of what the output should be like. So if the user puts in a word like this, then F should print first, followed by C, A, followed by I, and they should print in the same positions as they are in the string, right? So now let's start with header files, hashtag include stdio.h, hashtag include string.h because we're using strlen, and hashtag include windows.h. We're going to have a function called delay that is going to take no parameters, just going to provide a delay in milliseconds. Int main, we have variables, of course. We have a handle type variable, which is nothing but a type def. Remember, we discussed type def in the last session. And this is a type def for void star, which is a pointer to no specific type. Why we need it, I'll come to shortly. In windows.h, it's type def, right? So we stick to handle. And the variable name is going to be, now this is going to give us access. Of course, we'll have to use a function first, but it's going to give us access to the console or the screen buffer, which is part of the operating system. Then we have coord, again coming from windows.h, which will allow us to set the coordinates on the screen. That is the x and y coordinate. Name of the variable. You can change these names, the type should remain the same. Then we have char, str1, that's going to be 50 characters. And then we have integers, length equal to 0, middle equal to 0. We're going to use middle to trap the middle index of the word or the string. And then we have int I equal to 0, comma j equal to 0. Now we'll initialize wstd out using a function which is get std handle, and this is going to, if successful, return a pointer to a structure which represents the console buffer. We need to pass in an argument which is a constant, again defined in Windows NT.h. Now I'm not going to go into the specifics of the operating system, but the name of the constant is std output handle, and this is an unsigned number. So once that is initialized, we set destination quad dot, and y will refer to the row. So we set the row to 10, let's say. Right? Once we've done that, then we ask for the word. So printf, enter a word, and then scanf %s, comma, str1. Once we have the word, we can get the length. So length equal to strlen of str1, and then we assign to middle length divided by 2, right? So we get the index of the middle character, and j will be assigned length -1, so we get the last index in the word or the string. So once we have these initialized, we can start our loop. For I equal to 0, we don't need to set j, we've already done it. Condition will be I less than equal to middle and j greater than or equal to middle, right? Because j is moving backwards, and then I plus plus and j minus minus. Hope you're with me so far. Now within this loop, we'll set the coordinate for the column, right? First using I and then using j. So dest coord dot x equal to I. Then we need to use a function called set console cursor position, specifying the buffer. So wstd out, comma, and the destination coord. Right, so this will position the cursor at this particular column as indicated by I. Once we've done that, we print the character there. So printf %c, comma, str1 of I. Then we do the same thing for j. Right, but before that, we call delay to provide that delay in milliseconds, which we'll of course define later. And we say dest coord dot x equal to j, and then set console cursor position wstd out, comma, dest coord. And then we print the character at that position. So remember, j is starting from the last index and therefore be printed at that position, right? Comma, str1 of j, right? That ends main. We need to define delay here. So void delay, and within that just sleep. You're familiar with this now. 1000 milliseconds. And that's all. Right, so let's run this now and see the result. Okay, let's print somewhere instead of printf, and that's here. So enter a word. Okay, so it's not actually giving us the output we need. Why is that? Here we haven't called delay. Right, so let's call that there and let's see the difference now. Enter a word. Oh, let's put it in caps because it looks better actually on screen. Right? So you can play around with this program after the session. Moving on. Write code to have a letter fall down the screen. So again, let's go back to code blocks and start a new file. And again, hashtag include stdio.h, and then hashtag include windows.h. We don't really need any other header files. If we do, we can add them in later. We have void delay again. And you know what that will do now? Int main variables again handle, and I'm going to stick with the same variable name. You can change it if you like. And we need coord. We need just one character, so char ch. We'll initialize that to a character, let's say x, right? Because that's what will be printed on screen. And now we'll have int I, comma j, or let's say I equal to 0, comma j equal to 0. Now what we need to do is, of course, initialize wstd out equal to get std handle, and we need to pass in that argument, which is the unsigned number. So std output handle, right? Once we've done that, dest what we are setting the row dot y equal to 10. We can set console cursor position, and again we need to specify wstd out, comma dest board. Right, so that will be positioned at that row. And now we can start our loop. We can say for I equal to, we can change that. We can say I equal to 10 instead of having it as 0, comma j equal to 10. We'll continue as long as j is less than, let's say, 100, and then I plus plus and j plus plus. Within this loop, dest coord dot y equal to g, and set console cursor position WSTD out, comma, destination code. Right? And then we set now we've set the row, we can set the column. So dest quad dot x equal to I. And then printf %c comma ch. Okay. After this, we can call delay. And then because we don't want that character being printed on screen all the time, it should print on screen, then disappear, then print on the next row and the next column, disappear, and so on. So how do we do that? We can just call the operating system command to clear the screen. So just system and then CLS. That's the Windows command to clear the screen. Okay. Now we need to define delay. So void delay and just sleep with 1000 milliseconds. Right, so let's run this now. So you see how this works. But it's a little slow. To make it faster, you can reduce the sleep time to, let's say, 50. And now you can have it tumbling like that. Right, so you can play around with this program as well. This ends our session for today. In the next session, we'll be talking about file I/O. Till then, take care, stay safe. Bye.